Siemens. Oren, thanks for talking to me, and thanks so much for contributing to this week's What's the Scoop, talking about 22 trends. It's been fascinating read. We've already published half of it. We've got another number of contributors to publish this coming week, and I know yours is in that list. Some common topics came up and some not so common topics. One that did come up and that you very practically brought up is the whole sustainability issue, the whole kind of state of the planet, and what's going on there, and the carbon footprint and environmental impact of electronic manufacturing. Talk me through your views on where that's going as a trend and what it means for manufacturers.
Okay, so first of all, I want to say that Siemens in general and Siemens software is putting a lot of effort now on sustainability. So for some extent, it's not only let's say my idea or my pitch here. We do have a new VP sustainability, and the idea is to take all of the different engineering applications we have, CAD design, PLM, the whole suite, and try to understand how do we also allow better sustainability in general. So when I saw that, and I said, okay, I guess this is serious. We should also think about the angle of where do we come in play here when we talk about the electronics design to manufacturing flow, and how do we bring sustainability. And when I pitched to this new VP that we want to be in, they're like, yeah, but electronics is you're not that bad, and you're helping save the world, and it's really, it's those big coal plants. And then I told her, that's the perception, right? So again, people deem us as, these saviors, and then we're going to make everything great, and we're helping you go paperless and digital. And then it's all, but actually there's piles and piles of these cell phone chargers, right, that we all chuck away. And I have about 10 of them here in my drawer from the last, 6 different models. And that's a good example. They might be in some big pile of rubbish, in some dumpster where kids are, trying to find some food. Someplace, so and then you understand that we electronics manufacturing has been able, I think, to get away from it for the last couple of years, because there's been worse cases of more pollution and higher carbon footprint. But when you see these disasters, and I don't know if you can associate a tornado, some people say that you can, that deadly tornado in Kentucky, and if you can associate it with, some people say it is global warming because it was extremely hot. Some people are saying it's just a freak accident, happens once, but it's supposedly the longest tornado ever recorded in the US.
Yeah, and too many freak accidents.
Too many, right? So, now I think the scrutiny is coming to the electronics industry, and with the life cycles evolving so much, and we have to go and buy a new phone virtually every 18 months because the old one can't work anymore. And upgrading, you can't really upgrade the memory, you can't really upgrade the storage, right? I mean, these devices are sold as a module, and it's creating a lot of waste, right? Electronic waste. And I think this is gonna mean that we have to pay more attention. And we have now a big MES project that one of the specifications, and this is the first time I've seen it, is energy consumption for machines, energy monitoring, energy alerts. And I said, okay, we haven't done that. Can the machine do it? Well, some can, some don't. So, but you see that customers are starting to understand.
They're taking it really seriously.
Right? I think to some extent.
Yeah, I think you're absolutely right, Oren. I think it's really interesting. I think manufacturing might be part of the solution, but it's also definitely part of the problem. And we have to look at how we manufacture stuff. And if we're going to improve something, and we know this from every single element of every single process, if we're going to improve something, we have to be able to record it and understand it. So traceability is a huge part, and that's a big part of what you do at Siemens. So if you can add environmental elements to that, and then from an enterprise point of view, if we can look at the carbon footprint of a product when it's manufactured as well, and we can, I think some of the supply chain issues around very lengthy supply chains are costing us more CO2 than they perhaps should. So shorter supply chains are potentially a solution. So I think there's a lot that can be done, and I think manufacturing has a very, very important role to play in that.
And then, you know, we always talk about the shift left, right? I mean, that in many cases, when you come to manufacturing, you want to start manufacturing tomorrow, well, there's not a lot of things you can do, right? The BOM is set, the CAD is set, the process. So if we can left shift it, and when we're still in manufacturing engineering and we're planning the build of process, and we're saying, how are we going to build this device? We need to start making sustainability decisions. I mean, for example, the reflow oven, are we going to do it very hot, but, you know, very quick, or maybe we take a couple more seconds, we reduce the temperature, we reduce the energy consumption. That's a very simple and kind of, you know, very practical way to save energy. After the big Fukushima disaster in Japan, where the Japanese had a big cap on electricity, they couldn't put you know, air conditioners, and they couldn't use the reflows. We had a lot of customers come and tell us we have to change the whole profiles of the ovens because of this energy. And so it can be done, and you can think of it. And the other thing, another example is, you know, most electronics manufacturing is done on the first floor of the basement because the machines are really heavy. But I've seen cases where people say, I want to buy light machines that I can stack them on the second and third floor, then I can take less space, you know, which again has an environmental impact. I can leave more, you know, more grease, more grass around. I can have a less and stack it up, and also be closer to the city, which means maybe less trucks, less transportation. So we can think of all of that, and we really start to simulate how the manufacturing process is going to be done. And then I really would like designers, when they're designing the next product, to think about the sustainability, the sourcing, the manufacturing, the process. If they're going to do a lot of things there which require a lot of pressure, then that yields to energy consumption. So we have to start, you know, thinking about this, and not only about design for cost, right? Design for manufacturing,
sustainability,
and design for test. We've got to think about design for sustainability, because this is a ripple effect.
And I think there's a lot to offer, and there's a lot to change. And you just talked about that very small example of reflow ovens. The issue with reflow ovens isn't the temperature they're at, it's when they have to ramp up temperature or they have to reduce temperature quickly. So just sustainable production planning is going to help that. And if it helps in terms of sustainability, it's probably going to save some energy and make some financial sense as well. So there's, you know, there's value add in there as well. So we look at the whole sustainability issue, and it segues quite interestingly into another thing you mentioned, and that's EVs. We're seeing EVs as a savior for the automotive industry in terms of sustainability. That has to be done right in terms of sustainable manufacturing as well. How significant do you see the move from internal combustion to EV for the automotive electronics sector?
So I think what's changing now, and maybe, I mean, obviously it's a massive change. There is much more electronics in an EV compared to a traditional combustion engine. Some people say 10 times more. I've seen research that says maybe even 50 times more, but there's much more ECUs. There's many more controllers. There's much more PCBs in an electric vehicle. I think the big change now is this commercial EVs, where, you know, many cities in Europe are saying that by 2024, they're going to mandate that every delivery van, every one of these Amazon, the Post, all of this stuff is going to have to be done by EVs. And you're right, 2024 is like 3 years from now. So that's something you've got to start manufacturing now, because you will not be able to get into Amsterdam with a regular combustion transit. So all of these companies are going to have to buy these fleets of EVs, which means a lot of EV manufacturing, which means designing all of these EVs, all of these manufacturing, all of these components, and the AC/DC, and the converters, the charger, the in-vehicle charger. And I think this is going to cause a very significant demand for commercial EV electronics.
No, I absolutely agree. And it's one of the areas of demand that's been driving the industry this year, and it's seen as a big driver. And interestingly, we have this strange situation where you've got the automotive industry on this really strong bounce back. You've got really strong order books, and that's contrasted by problems in the supply chain. You, like most people, don't see this supply chain challenge going away fast.
So I mean, I don't see how you could think it would go away if demand is just going to increase. I mean, you know, locally here, I wanted to, renew the leasing and get a new car, and there's basically no cars. So you want to buy a car, and many dealers tell you we have no date of shipment of, new cars.
Yep.
6 months, 9 months, 12 months. You can't order because they have no clue when they're going to get ones. So it's very clear that this, at some point, I imagine that the demand is going to catch up with supply, and they'll build enough new fabs, right? And the chip makers will bounce back and increase capacity, and the shipping will also accommodate
equalize this in some way.
Equalize it, but I think the best guess is 18-24 months. So definitely for the next year, we should see the same issue, which means again, design for supply chain, right? Making strategic, every BOM component becomes now a strategic asset. It used to be that long lead items, you had 1-2 long lead items, you would say, okay, I need to do strategic sourcing. And if you were a smart guy, even a small startup, in your drawer, you had 50 of those, long lead items. But now basically, if your BOM is 200 components, 180 are long lead items. And you've got to do strategic sourcing and strategic planning. And you've got to make decisions, because maybe you can get them in Germany, but if you're going to build it in Mexico, who knows?
You can't.
Maybe so you've got to start thinking really early about these things. Otherwise, you're going to get stuck.
Yeah, and 180 long lead time components, it only needs one not to be there for that thing to not ship. And that leads people to problems with work in progress. It increases inventory. It puts more risk in the supply chain. It absorbs cash. So it's challenging times for the, for the whole manufacturing industry. It's not going to be a dull year, is it?
No, and then you're going to do all of these changeovers, right? And ECOs and change this capacitor to a different capacitor where it's slightly bigger, it's slightly heavier. You've got to adjust the stencil. And since we're all doing this small batch manufacturing, and at the end of the day, the whole batch is 100, it's going to take you 30, 40 units to understand that it's behaving different in the functional test than the old capacitor. And maybe the temperature resistance is not
maybe it needs a different thermal profile.
And now half the batch is gone down the drain. So I think you really have to do that. And Siemens made just a strategic acquisition of Supply Frame last year, where we bought the. And we're seeing
looks
now
like a smart move now, doesn't it?
Yeah, right. It looks like a very smart move. And now the only question is, how do we get that data into the right people when they're making the decisions in design, in the schema, as early as possible, but also in manufacturing engineering, the guys programming the machines, doing the functional test, that they understand the availability, end of life, risk of the components. Getting that data, making sure it's up to date, and also feeding the data back to the chip makers so they understand how they need to manipulate their supply so they meet market demand and don't make components that nobody really wants to use, because they have very limited bandwidth, and they also want to make really what's going to get used. So
you're absolutely right, Oren. It's all driven by data. And we have to convert that data to insight, and we have to turn that insight into value. And that's where companies like Siemens Software are so important. Thanks so much for sharing your insights. Really enjoyed talking to you about it. Have a wonderful break, and I hope the new year is successful and at least safe. Thanks again for your time. And